All right, so let's solve this differential equation. Let's first rewrite it as 2 plus x times dy dx. And let's add xy to both sides. So this will be equal to xy. And now let's bring all the x terms to the right and then y terms to the left. So this is simply then going to be dividing each side by y and multiplying each side by dx and dividing by 2 plus x. Let me just go step by step so it's not overwhelming. So it's like 2 plus x dy multiplying both sides by dx. We get x, y dx. And then divide each side by y. And then divide each side by 2 plus x. And then so on the left, you'll get 1 over y dy being equal to x over 2 plus x dx. Now we can set up our integrals because we got the variables separated. But we have an issue here. We're going to need to use some clever U substitution. The left side is not an issue to integrate. That's just going to be the natural log of the absolute value of y. So this side we got to figure out. So what we're going to do is we're going to make u equal to 2 plus x. And then du will just be dx, which we got, of course, but we need to get that x. So what we're going to actually do is to solve this for x, so we'll get u minus 2 equals x. And we're going to rewrite this as the top, as that x being u minus 2 over u du. And this is then keeping the right side. You can think of this as u over u minus 2 over u du. Because u over u is just 1, and this becomes easy to integrate. This just becomes u, integral of 1 is u, minus 2 times the natural log of the absolute value of u. So then we get the natural log of the absolute value of y being equal to u minus 2 times the natural log of the absolute value of u plus c1. And then let's resubstitute 2 plus x in for u. So look at the natural log of the absolute value of y as being equal to 2 plus x minus 2 times the absolute value of 2 plus x plus c1 Now, the thing is that this 2 plus that c1, when you add those, that's just some other constant. Let's just call that c2. We just say c2 is equal to 2 plus c1. Because again, it's just some other constant. This is again why I like to have a habit of writing c1 first and c2. And so then we don't get, because if you just write c, you can't have every constant be just c. You have to have, subscript. So then this could be the same as the natural log of the absolute value of y being equal to x minus 2 times the natural log. X minus and what we're going to do is put that 2 as that exponent. Maybe not, well, I guess once we omit the absolute value signs, we can. So minus 2 times the natural log of the absolute value of 2 plus x. So plus c2 at the end. We'll put that plus c2 at the end. Okay, so now let's go ahead and raise e to this whole group. So we're gonna get y being equal to e to the x minus 2 natural log of 2 plus x plus c2, and we can now omit the absolute value symbols. And we can rewrite this as e to the x times e to the natural log of 2 plus x to the negative 2. Again, using this as your exponent and using the sum property times e to the c2. Because we can just add those. And again, removing this using the power property of logarithms. Now, e to the c2 is just some other constant. We can call that a. And then e to the natural log of whatever it is just going to be the natural log, or just that 2 plus x to the negative 2. So these get omitted. So then this just becomes y being equal to, let's put the a in front, a times e to the x times 2 plus x to the negative 2. And they're probably going to have this 2 plus x in the denominator, I'm going to imagine. So they'll probably see your answer as a e to the x over 2 plus x squared. And there you go. That's all there is to it. And so I hope that helps. Good luck.